We are now going to jump from the fun basics of magnetism that you possibly learned 10 years ago to some more quantitative things, but we need to actually have a simple system that we can start doing our calculations on. So we're going to now be talking about compasses near a wire. Now keep in mind that the reason we're talking about compasses is because the compass needle is a tiny little magnet. So we're actually using compasses as an indicator of magnetic field. So the wire in this picture is the cylinder that you see there. Now this is fundamentally a three-dimensional picture. So this is something I've warned you about before, that most charge situations can be simplified to 2 dimensions. Magnetism is fundamentally going to be a 3-dimensional phenomena. So in this case, you can get a nice perspective view of the problem based on because the book has some really good artists. You would possibly want to do a top-down view if you were trying to draw this yourself. If you can draw in perspective, that's great, but I know I can't do that. So we will talk later about how you can actually represent some of these directions. But initially, we have a wire, we have some magnets around it. Now, the other piece of information is that that direction north is literally north of the Earth, right? So where I am standing right now, I know where north is because that's towards downtown Decatur. So my little magnets point towards north. So we're using the red side to represent north. So my little magnets all point towards north because that's what magnets do, because by default they're interacting with the Earth's magnetic field. Now this corresponds to no current flowing through the wire, right? So there's a chunk of copper hanging out near some magnets. The magnets don't care. Well, now we can actually put lots of current through that wire. And what's going to happen when we do that is we're going to see something change with the magnets. Now, I call this lots of current because if you only put a little bit of current through the wire, you're not going to see a very big effect. And so that's why this needs to be a lot of current. Now, with a lot of current, right, notice we have the current here, we actually see that our magnets no longer point the same direction. That in the case of no current, they all pointed towards north, right? Now, this one still points towards north, but this one points a different direction. That one points a different direction. This points the opposite of north, right? We see that they point different directions, and it looks like they kind of are forming a circle with the direction they point. But the important thing to note is that we've now basically overridden the Earth's magnetic field. So something that the book doesn't go into, but I want to remind you about, is that in this case, it isn't that the Earth's magnetic field has disappeared. Something that you might anticipate is going to happen is that we can add magnetic fields together the same way that we could add electric fields together. But the Earth's magnetic field is pretty small. And as long as you have enough current, the magnetic field from the current is going to be very large. So this is a case where we would consider the magnetic field from the Earth to be negligible. And that's something you're going to need to do to simplify almost all magnetism problems. So we're going to think a little bit more about these directions and how we represent that and how we understand the direction. We said that it looks like these magnets are basically forming a circle. And what this might remind you of are the circles that you typically see if you put little iron filings down in magnetic fields. So this is, again, something that you've possibly done in a science class earlier in life. This here is a wire that is coming kind of at you, basically. Again, this is fundamentally 3 dimensions. So that's coming more or less out of the page. And then you can see that there are circles here, right? Now you can see the circles better closer to the wire. As you get farther away, they get a little less circle-like. But in this case, these are little pieces of iron that are aligning themselves with the magnetic field. So that's why you get circles. So we use iron filings, they respond to magnetic fields, and they kind of align themselves with magnetic fields. But it's not really easy to get anything quantitative from this. We'll have to set up some equations to do that. But if you've seen iron filings used before for visualizing magnetic fields, that's all we're trying to do here, but in a slightly less messy way. This stuff is really messy, so I'm usually going to use compasses instead. Now, the book points this out at the end of this section, and I'm going to point it out now. There's a little bit of a sleight of hand happening. That initially we talked about bar magnets. I've now shown you magnetic iron filings showing magnetic fields. And again, most people study magnetism in school, possibly in elementary school. But normally what you're studying there are these permanent magnets, horseshoe magnets, bar magnets, discs, balls, all sorts of things like that. Now, so initially when you're thinking about magnetism, you're probably thinking about those types of objects. And now we've been talking about wires. Okay, fine. But if you're expecting to go back to bar magnets, you're going to be disappointed. And the reason is that when we go to do calculations, the calculations that are not too hard are going to be straight wires, loops of wires, and coils of wires. And I'm not going to go into this yet because these things will be expanded in future videos. We haven't really done them yet. And you look, here's actually a calculation for what that looks like. Notice that those calculations look not too hard. And again, in future videos, we'll go through these equations in detail and come back to these key magnetic fields. We'll come back to this model. These create simple magnetic fields that we can understand. These permanent magnets create really complicated magnetic fields, and it's really hard to understand them. So there is going to be one section of the book that looks at magnetic materials, but all we can really do at the introductory physics level is talk about it in a very qualitative, conceptual way. So I just want to point out that the reason we're focusing on wires and the magnetic fields of wires is that they are simple systems. That means we can simplify problems into something we can calculate, we can understand it. These bar magnets and so forth are very challenging to understand, and actually the reason we can do some calculations with these at all is because we will find that we can actually simplify their fields in some cases to have the same shape as some of these, which are much easier to understand. So we're rarely going to come back to bar magnets in this class, but just know that that's coming. And the idea being that instead of asking you to understand very complex material science, very complicated things about domains and interactions between domains, you even need statistical mechanics and thinking about temperature to think about this stuff. Instead, we're going to practice the ideas of magnetic fields in these simple systems, and then later you can actually use some of these models for these complicated objects.